Dear students, thanks for watching my lecture. Today I am delivering my lecture on the physics first paper, chapter 5, work, energy and power. This is a very important chapter for our physics. In my previous lecture, I am trying to discuss about work done in case of the constant force. My dear student, in case of the constant force, we have to confirm two things. One is force and displacement. Always we take the displacement along the direction of the applied force. This is very important. Now, in my previous lecture, we see three types of the works involved in the constant force. One is positive work, another is zero work, and third one is negative work. Now I am trying to give some example for positive and negative work, and then my today's lecture I also try to find out different type of the cases to find out the work. Okay, my dear student, now we discuss about positive work, negative work and zero work. Already we discussed zero work. Now today's topics will be positive and negative work. Positive and negative work. Okay, my dear student, when work done will be positive and when work done will be negative. Now I discuss this part right now. Okay, my dear students, suppose this is the surface. Suppose this is a surface. Okay, surface. Suppose here has a block on the surface. Okay, suppose the surface is not a smooth surface. This is the rough surface. Okay, this is the rough surface. If we apply the force this direction, suppose the force is F, and if the body comes here because of the applied force, as we apply the force this direction, so the body move from point A to B. Now, as because of the rough surface, here has a create frictional force, the opposite direction of the applied force. Suppose frictional force is Fk. My dear student, try to understand what is happening actually here. We can see here has applied force and here has frictional force. The direction of the applied force and the direction of the displacement is same. The direction of the applied force is this, and this is the direction of the displacement. As the direction of the displacement and applied force is same, because of that reason, here angle between the applied force and displacement is 19 degree, applied 0 degree. The direction of applied force and direction of displacement is same. Work done for applied force in this diagram. Work done for applied force. Okay, now our equation is we need force, we need displacement and cos theta. My dear student, here we can see the value of theta is 0 degree. Suppose the magnitude of force is 550 Newton and displacement is 5 meter. Okay, now we put the value of the applied force 15 Newton and magnitude of the displacement is 5 and angle between applied force and displacement is 0 degree. So we put here 0. Now cos 0 means 1, 75 joule. This is the example of the positive work done for positive, work done for applied force. Now work done for, we measure work done for frictional force. My dear student, try to understand actually what is happening. Work done for frictional force, as the magnitude of the frictional force is suppose 0.5 Newton. So we just put here the magnitude of the applied force Fk, and displacement is S and cos theta. This is our equation. Now we put the value of frictional force is 0.5 Newton and displacement is 5 meter, and angle between we can see this is the direction of the frictional force and this is the direction of the displacement. So the angle between frictional force and displacement is 180. As the value of 180, so here is a negative sign, so we 2.5 joule work done here. This is the negative example of the negative work. My dear student, I think that all of you clearly understand actually what is happening here. Okay, my dear student, I think that all of you clearly understand my lecture, and now I am trying to give you the another example for positive and negative work. Okay, now we take another example for positive and negative work. Okay, my dear students, try to understand actually what is happening. Suppose here has an object, this is the surface, this is the surface, this is the surface, here has a object. Okay, now our the mass of the object is m. Now we want to take the object from this position to this position. Okay, this position to this position. Okay, my dear students, now our duty, we just taken the object from this position to this position. Okay, now we take, if you want to take the object this position from point A to B, this is the initial position and this is the final position. We know if this is the initial position, suppose we write here, this is initial position and this is final position. My dear student, if you want to take the object from point A to B, then you must need to apply the force. Suppose the direction of external force ext, this is the direction of the external force, and if the body go from point A to B, goes from A to B, then the direction will be upward direction. Okay, now we try to measure the work done in case of the applied force. Work done for applied force. Work done for applied force. Applied force. My dear student, our equation is, at first we put the value of here external force and displacement is H, and angle between the displacement and applied force is same, so we put here 0 degrees. So our equation will be fxt is the value of x. If the mass of m, then value of xt will be mg. So we put here mgs. So this is the positive work. Okay, this is the positive work. And you just try to understand, when the body goes from point A to B, we apply the force upward direction. But if you think, when the body comes here and the direction of the gravitational force downward and direction of displacement upward, so the angle in this case is the angle between the displacement and the gravitational force is 180. Because of that reason, if we measure the work done for gravitational force, in case of the work done of gravitational force, now we measure, we need at first force. The gravitational force is mg, displacement is h, and angle between the applied force and the angle between gravitational force and displacement is 180. So the result will be the value of cos 180 is negative, so the work done will be negative in this situation. My dear student, I think that all of you clearly understand what is actually happened here. So we can see, when any kind of the object goes from surface to upward direction, if any kind of the object, if you have taken any kind of the object from the surface and surface to upward direction, then because of the applied force, the work done will be positive, and because of the gravitational force, work done will be negative. Now our duty is to find out the work done when we taken the object from B to A. Okay, now we calculate how can we do this. Suppose this is the surface and this is the position, this is the object. Okay, this is now point A, and if we take this object from A to B, when we taken the object from A to B, then the direction of the displacement will be downward. H means displacement. The direction of the displacement will be downward, because we know the minimum distance between initial point to final point. Now this is initial point and this is final point. So the direction of the displacement always count from minimum distance from initial to final. Okay, now if we taken the object, if we have taken the object from point A to B, then we must apply force upward direction. This is the direction of the applied force. This is applied force. Okay, my dear student, always try to understand. Suppose if this is my pen, and if I take this pen from this point to this point, okay, if this, okay, try to understand the applied force, the direction of the applied force always upward direction. Okay, always upward. If we take the object from here, then the direction of the applied force always upward. Okay, you just try to understand. Now our duty is to find out the work done for applied force in this situation. Work done for applied force. Now we measure, as the direction of the applied force is upward, so at first we this is the external force xt, and direction of the displacement is downward, so we put here cos 180. The value of external force will be mg is the value of cos 100 will be 90. In this situation the work done will be negative. So when we take any kind of object from any kind of the point from the height h meter height from the ground level, and if we take the object from A to B, then the work done will be negative. But when we taken the object from point A to B, then in this situation if the object goes from upward direction from the surface, then because of the applied force we can see here the work done is a positive work. Okay, but in this scenario we can see when we take an object from any kind of the h meter height level from the ground level. This is the ground, this is the ground, and this is the initial point. If we take any kind of the object from h meter height point A to B, then because of the applied force the work done will be negative. But if we think the direction of the gravity mg downward, in this scenario if we measurement work done for gravitational force, as the direction of the gravitational force mg downward and displacement direction also same, so in this case as work done will be mg s cos 0. So we can write here mg s. This is the example of the positive and negative work. So my dear student, now I am try to clear you when we taken any kind of the object from ground to any kind of the height upward direction, then because of the applied force direction of the applied force is upward, so displacement also same direction, so work done will be positive. But when any kind of object taken from ground to upward direction, because of the gravitational force work done will be negative. But when we taken any kind of the object from height h meter height to downward direction, or to the direction to the surface, then because of the applied force work done will be negative, but because of the gravitational force the work done will be positive. Now my dear student, I am trying to give you another example. In case of the inclined surface, this is very important for us to measure the work when any kind of the object taken h meter height from the ground level on the inclined surface, or taken from h meter height to ground on the inclined surface. In case of the inclined surface, it is really very important to how we can measure the work in this situation. Now I am trying to give you the clear explanation. I think that this explanation will help you to measure the work in this situation. Okay, my dear students, I think that for calculating work, always we have to remember we must need the force, and we must need the direction of the force and direction of the displacement. Both two things is very important to calculate the work, any kind of the work. If you measure any kind of the work in your physics chapter, or solve any kind of the mathematical problem related to work done, always try to understand. At first try to find out the direction of the applied force and direction of the displacement. Two things is very important for measurement the work in case of the constant force. Now we give you the another best example. Suppose work done, our topics will be work done for inclined work done for inclined surface. Our duty is to find out the work done in case of the inclined surface. Suppose here has a inclined surface. Suppose this is the wall, this is wall, okay, and this is the horizontal line, horizontal line, okay. Suppose here has a inclined surface. The name of the inclined surface is AB, okay. Here we also give you another diagram. Suppose this is the horizontal surface. Now at first we give the explanation of this diagram, then we write this, okay. Suppose here has an object, okay. Suppose this is the B point, here has an object, okay. Here has an object. The angle, the inclined surface AB is a smooth surface. This is the smooth, at smooth surface, okay, and the distance of this smooth surface is S, okay, distance is S. If the mass of the object is m, we know the gravitational force will be mg. If this body go from point B to C, then how much gravitational force act on this body? mg. Suppose this inclined surface AB make an angle with the wall is theta, okay. Now our duty is to divide mg force into two perpendicular component. We know if this is the mg force, here has a component, the name of this component mg cos theta. This is the component, and if the body comes from point B to A, then which force is responsible, mg or mg cos theta? Mg cos theta is responsible for moving the object from B to A, okay. This mg force in this situation divided into two perpendicular component. One component is mg cos theta. Because of mg cos theta, the object which mass m comes from B to point A. As this is the initial point and this is the final point, so the direction of the displacement is also same. Suppose the direction of the displacement is S. Here we can see the direction of the force mg cos theta and direction of the displacement is same direction. So here we can write the equation of the work done. So in this diagram, we just measure work done for gravitational force, okay. My dear student, we just measure work in case of the gravitational force, okay. Now our duty is to write the equation at first. Our equation is W. At first we write the force as the direction of the gravitational force. This is the total direction of the gravitational force mg, as the body do not come from B to C, because this force cannot act on the body to move the object from point B to A. So this mg is a gravitational force and mg cos theta is a component of the gravitational force. Because of this component, the body comes from B to A. So this component of the gravitational force is responsible for work done. So at first we write the component of the gravitational force mg cos theta. Why we write this component? Because this component is responsible to move the object from point B to A. Now we taken the displacement. Our displacement is S. Now we take cos. This is our formula. Our formula is f is cos theta. At first we put the value of f. F means mg cos theta. Then we put the value of displacement. This is the displacement. Now we put the cos and angle between the force and displacement. The force direction of the force mg cos theta down B to A, and direction of displacement also B to A. So angle between mg cos theta and S will be 0 degree. So we can write here mg S cos theta. What is theta? The theta which is making angle with wall, inclined surface make angle with the wall. This is the theta. Okay, this is our equation. My dear student, I think that all of you clearly understand. If a person or any kind of the object taken from A to B, then this work done will be against the gravity, same amount of the work done, and this is the positive work, and in this sense this will be the negative. Okay, my dear student, always try to understand when we taken the object from point B to A. If the object goes from point B to A, then how much work done here? mg s cos theta. But if we taken any kind of the object from point A to B, then same amount of the work done will be happened here, but this work done will be against the gravitational force. This is our basic concept. Okay, now if this angle is present, suppose this angle is theta prime, we know as this is the 90 degree, so we can write theta prime plus theta plus 90 is equal to 180. As we know, the summation of the total angle of a triangle is equal to 180, so we can write this. Now our duty is to find out the value of theta. Theta prime plus theta is equal to 180 minus 90. Theta prime plus theta is equal to 90, so we can find out the value of theta. We can find out the value of theta. Theta will be 90 minus theta prime. Now we put the value of theta in this equation. Okay, if we put the value of this equation, then we get the special things here. We get another equation if we put this value. Okay, my dear students, now we put the value of theta in this equation. mg s cos 90 degree minus theta prime. We know mg s 90 degree is even number, so operator cos turn it into change into sine theta prime, and this is the positive sign because the angle is all the positive quadrant. Okay, so here we get another equation. When we use this equation at the time of solving our mathematical problems, now we discuss. If this is a inclined surface, and if this inclined surface make angle with the wall, suppose this is the wall and this is the inclined surface, and if this is the magnitude of the displacement, in this scenario we always use this equation mg. Suppose m is a mass of the object, mg s means the distance of the inclined surface, mg s cos theta. When the angle is given this angle, when the inclined surface make angle with the wall, that is very important. If the inclined surface make angle with the horizontal line or base, horizontal line or base, in this situation we write this equation mg s sin theta prime. Suppose if this is the inclined surface, and this inclined surface is AB and base is BC, and if the inclined surface make angle with the horizontal line, in these cases if this is the length of the inclined surface, in this situation we measure the work mg s sine theta. My dear student, I think that all of you clearly understand. Now I give you two mathematical problems. After solving these two types of the problems, we will also very clear. Okay. My dear student, if the mass of the object is 2 kg and this is the 5 meter, and if the value of theta is 30 degree, then what will be the work done in this case? We just put the value. M is 2 kg and G means 9.8 and S means 5 meter and cos 30. This is the simple problem. And if this angle is 60 and this is the 5 meter and the mass of the object is 2 kg, then what will be the work done when the object comes from point A to B? We just put here M means 2 kg, G means 9.8, S means 5 meter, sine theta means 60 degree. Okay, now we give you the another special problems. I think that if you solve these special problems, then it will be very better for you. Okay, my dear student, suppose this is the smooth surface. The length of the smooth surface is, suppose this is the smooth surface. Okay, this is wall. Okay, suppose this is the inclined surface. Suppose this is the inclined surface. Suppose I give you this angle. This inclined surface makes angle with horizontal 30 degree. Okay, now I give you, suppose a person, here has a person, the mass of the person is 40 kg and this person taken a object is his hand, and a person taken a object in his head. The mass of the object is 10 kg. Okay, suppose the man goes from point A to B. If the length of the inclined surface is S is equal to 20 meter, then how much work done has been done against the gravitational force? Okay, now our duty is to find out work done. Okay, we know W is equal to mg s cos theta or sin theta as angle is given with the horizontal line. So we write this equation. Suppose the mass now we calculate here total magnitude of the force. Total magnitude of force will be count for the total mass. Suppose the total mass is 40 and 10. Okay, this is the total mass, and value of G 9.8 and value of S will be 20 meter and sine angle is 30 degree. This is the problem. My dear student, I think that all of you clearly understand. This lecture only deliver for the constant force. In my next lecture, I am trying to give you the clear explanation of the in case of the how we can measure the work in case of the variable force. My dear student, if you do not see my previous lecture, then you just click the a link is given in the description box. You just go there and see this lecture very easily by clicking the link. Okay, and if you face to understand any kind of the section or any kind of the part of this lecture, then please write down your comment on the comment section. I am try to give you the clear explanation of this particular part. Okay, my dear student, I think that all of you clearly understand. If this video you enjoy, then please write down your comment on the comment section and don't forget to subscribe my channel. My dear student, I am trying to give you the more basic information that will really help you for solving any kind of the mathematical problem. So my suggestion to you, you just not see this lecture, you just practice this particular part again and again, then you can able to develop yourself in physics. Okay, dear student, thanks to all for watching my lecture. Thank you.